So ray optics.
Okay.
So first of all, what is the meaning of a ray optics? There are two type of a nature in physics we will learn. Even though wave optics right now in this academic year is not in our syllabus, but we will discuss about it as a later part. So we are considering that a source of a light having the nature that is called as a ray. It means a straight line, and that is called as another nature. It is called as a wave nature. So we are right now aware about such type of a wave nature. But we are also aware about there are different type of waves. It is called as a circular, cylindrical, so such type of or planar waves. But we are just primarily aware about this thing. It is called as a wave nature. Simple thing. There are so many properties that we will discuss about those properties. Some of the properties are followed by both. Let's say we can discuss about very first property is called as a reflection. Another thing is called as a refraction. But one property which is something different, which has been not followed by the ray optics, but it is followed in the wave nature. It is called as interference and rarefaction. Such type of properties are there. So first of all, I'm mentioning those properties which are common in a ray and a wave nature. That is called as a very first property, which is called as a reflection. And another property, it is called as a refraction. So these are the two common properties followed by the ray optics. So in this chapter, we will solely focus on the ray particles, or you can say ray nature of the optics. And optics is a branch of the physics which is dealing with the light, vision, instruments, or you can say magnification. Such type of things been measured under the branch of the physics. It is called as optics. So we will first of all just focus on very first property. It is called as a reflection. What is the reflection part? So for the reflection, there are so many things. The basic necessity is that there must be a surface which must be non-transparent, which is not allowing our ray to pass out straight away. So let's say in this passage, I am considering my ray is impinged on the one particular point on this surface. I have placed one surface. I have applied my ray, and immediately it is not finding it out another media or maybe other way to come out of this system. So automatically reflected from that point. So there are two things. Very first thing is called as the incident ray, and another thing is called as our reflected ray. So I am drawing one perpendicular for our understanding. So very first ray, I am just naming it is called as our incident. So this one is called as the incident, and this one which is coming out, that is called as the reflected. If it is reflected, then it is having one more thing. It must have some angle. This is called as the incident angle, and this is called as a reflected angle. So for a reflection, there are primitive characteristic it must follow. There will be a single media or single medium. If there are more than two mediums available, then we will go for the refraction. But right now, when my incident ray is applied on one particular point, and from the same point it is reflected in another direction, so it called as the entire media is common. Let's say this process happen or this process occur in the media of air. So same way, my reflected ray is coming out in the same fashion, in the same angle, with the same angle with the normal, and it is in the single medium. So this entire process happen in the single medium. Someone asked me that, sir, it is only possible in the air media. No, it is not possible for the air media only. It is possible for the any media. If you are putting entire system in the liquid, if you are putting entire system in the water, if you are putting entire system inside and you are observing from inside, then you can say that reflection happened. So if I am putting this entire system in front of your screen into the water and applying one ray, incident ray, so I can just get the same reflected ray into the water as well. But if I am watching from the outside of water, then it is for the cause of a refraction. So be careful. Reflection is only happening in the single medium. If there are more than two medias, then we have to compromise with the reflection. Second thing is that angle of incident and angle of reflection both are equal. So you can say that angle of I and angle of R both are equal. You can say theta of incident. Yes, you can name it like that. And theta of reflection, both are same.
Sir,
Bolo.
sir, single medium वालू sir पांचों repeat.
So ray is having the nature, it is called as a straight fashion. तो straight fashion में ray incident हुआ कोई particular point पे, and then after that it has been reflected from that point in another direction. You can say it has been deviated. So there are two conditions we have seen. One is called as our single medium must be there. Second thing is that angle of incident and angle of reflection must be there. And the third media, both are making an angle with normal. In a normal scenario, normal is a straight line. You can say that you can name it as n and n dash. It is the imaginary line which is for our conveniency. We will draw it. Sometimes after interval of a time, we will just imagine it. So it is not actually existing. If someone is saying that I want to see the normal line, it is not normal line. It is not available. You have to just imagine that whichever surface you have drawn one imaginary line, and after drawing that imaginary line, it is quite easy for you to understand that incident angle and reflected angle. So this is the very primitive conditions of a reflection. After reflection, there are so many people are asking that reflection happen in the mirror. Yes. So there are such type of mirrors we will have, such type of lenses we have. So reflection can happen into the which medium or which places. So you have very first thing is called as there are two type of mirrors. One is called as a plane mirror, and another thing is called as our perpendicular mirror, or we can say that curved mirror. There are two type of mirrors you have. Very first mirror is called as a plane mirror, and another is called as a curved mirror. Into the curved mirror, there are two subcategories. One is called as our concave mirror, and another thing is called as a convex mirror. So these are the types of the mirror. Same type of lenses are also available. So right now we will just discuss about that reflection, and in the reflection happen in the two type of mirrors. Very first is called as a plane mirror, and another thing is called as a curved mirror. Now initially there are different type of a question can be asked from the plane mirror. Very first thing is that I have drawn such type of a mirror. Mirror is a single thing which is one type of a glass. It's another surface has been coated and it is covered, so our ray cannot pass through it. Let's say this is the angle theta. I have a place two mirrors m1 and m2 in a such a manner that I can receive my image. There are number of mirrors you can place. So with the help of one formula, you can have a number of images, and if you know that at which angle you have placed these two mirror. And first of all is called as a number of images. Let's say I have a place one ray over here, and I have placed two mirrors at the angle of 45 or 30. So what will be the number of images? You can imagine that such type of scenes you may have seen in a barber shop, that you are going for haircutting. In front of you there is a mirror, and at the back side there would be another mirror. And if you are just focusing on a front mirror in front of you, you can have such type of illusion there is number of images in your back side. So same scenario will happen over here. You have two mirrors M1 and M2. Number of images are there. So number of images will be what? So there are two type of formula. One is called as a 360 divided by theta, and there would be n equals to 360 upon a theta minus 1. So that is n is called as a number of images. Now which formula we have to use when? If after finding it out my answer n is equals to odd, then I have to stop over there. If 360 divided by, let's say, 45 degree, and if my answer is odd number, then it is the number of images available to me. But if my number after dividing 360 by theta is even number, then I have to subtract 1 from it. So n is even, then we have to just to find it out this thing. So the simple thing is that what I am putting a very simple manner over here is that rather than putting such type of thing, if you have a 360 by theta is equals to odd, then you have just directly switch over to n. And if your 360 upon theta, it is called as a even, then subtract 1 from that. Then you can find it out number of images. So that is one must thing is that number of images must be the odd number. Because let's say 360 divided by 90 I am putting. So you can have a 40 minus 1. That would be 39. It means that always your number of images, whenever you have either single object, if there would be a single mirror, then we are not putting such type of formula. But if you have a two or more than two type of mirrors, then yes, it is a such type of a thing where you can put this formula. It is quite clear for you to find it out number of images. So this is the simple formula. One more thing I want to conclude over here is that you may have seen there are some of the um, uh, illusion people are creating in a room. There are number of mirrors, and from that you have to find it out your path. So in such type of thing, you can find it out. There are number of images of your own side, your own body's reflection may occur, and there are number of images will be there. It is a such type of illusions. So at that time, you can find it out in a such type of a rooms. Number of images will be like that. If I am giving you such type of example, let's say there is one room on. I have placed one object over there at the center of it. There are number of rays coming out from that object in all those directions, and you can have a hexagon over here. So what would be the number of images? So you have to just consider that all hexagon contains a different type of angle, that is called as a 6 degree, six angles having 60 degrees. So you can have a number of images. It is called as a 360 minus upon 60. So you can have a, let's say, number of images are called as a 6. This is called as a what type of number it is. It is called as an even number. So you have to subtract from that. So that is actually 5 number of images you have. This is how you can calculate your number of images from our two or more than a two mirrors. So this is how it has been calculated. So it is quite easy for you to understand this thing. अभी curved mirror की बात कर रहे हैं. What are those curved mirror? One is called as a
Sir,
concave and convex. So you have learnt in your 10th as well. Even though we have to just discuss about it. That is called as a concave mirror.
sir,
And another thing is called as a convex mirror. Very first thing is called as our convex mirror, and another thing is called as our concave mirror. Purely we can just say it as it is entirely a circle. Let's say I'm drawing a circle, and from that I will just cut it out very selective part. So let's say this is my first circle, and let's say I'm just putting in front of you another circle, and from this first circle I'm choosing very small internal circular part. So that is my internal circular part is like this one. It is called as my concave type of mirror. Same is the course I am cutting over here, and let's say I am putting in such a manner that it's an internal surface and external surface. Remember like that one. If I have a drawn such type of a curved part, and I will mention that if it's an internal surface is reflective, then you can say it is concave mirror. And if it's the outer surface is reflective, then it is called as our convex mirror. Actually, both are curved mirrors. Entirely, just consider that we have such a ring. Its internal surface is we have just coated. तो either outer surface is coated. कनकेव में क्या होता है कि भाई हमारा जो आउटर सरफेस होता है वो कोटेड होता है कलर से. तो अभी हमको चीज जहां पर ही रखनी है, अंदर ही रखनी है, तो जहां पर दे दिया रे तो उसी में घूम के वापस आएगा. और यहाँ पर कन्वेक्स में क्या होगा, आउटर सरफेस इज रिफ्लेक्टिव, तो अंदर वाला जो होगा वो कोटेड होगा. तो यू कैन से दैट हियर इनर सरफेस इज कोटेड. So don't try to just mug up and just remember this thing, because not outer or inner, or you can say that is been or outer surface is coated. So if your outer surface coated hai, तो let's say कैसा होगा. So I am drawing one more figure for you, and it is like this one. This is like curved part. This is a selective portion I have just placed in front of you, and just I am putting outer surface has been coated. Outer surface को coat कर दिया. तो लेट्स से अभी यहाँ पर मेरा ऑब्जेक्ट रखा हुआ है. दिस इज द सरफेस वेयर इंसिडेंट रे हैपन, और उसको मैं नॉर्मल कुछ ड्रॉ करना चाहिए. जैसे कि भी मेरा कर्व्ड सरफेस है तो उसका 90 डिग्री या नॉर्मल पे कुछ ड्रॉ करना है, तो लेट्स से दिस इज माय नॉर्मल. तो मेरा जो होगा आफ्टर इंसिडेंट रिफ्लेक्टेड रे विल बी लाइक दिस वन. So incident and reflected will be of equal angle because it is in the same media. And now that you can find it out, its internal surface has made that ray reflected. That is why it has been remembered as a concave. Why? What happened in a convex surface? वैसे का वैसे ही रख सकते हैं आप. But what I will do is that my internal surface is coated. तो what people are trying to do is that यहाँ पर राइट साइड में है और लेफ्ट साइड में है. कुछ लोग ऐसा याद रख लेते हैं कि ऐसा किया हुआ है, कुछ लोग ऐसा करके बोल देते हैं. नो, नथिंग लाइक दैट. डोंट पुट इट लाइक दैट. सिंपल मैनर ये है उसका याद रखने का कि इंटरनल सरफेस कोटेड है और आउटर सरफेस कोटेड है. यहाँ पर लेफ्ट साइड में कनकेव में क्या था, आउटर सरफेस कोटेड था. अभी कन्वेक्स में क्या है, योर इंटरनल सरफेस इज कोटेड. तो अगर मैं यहाँ पर इंसिडेंट रे डालूं तो another surface has been coated, so my reflected ray would be something in opposite direction from my incident. तो दोनों में reflection होता है because it is a purely mirror but curved mirror. So angle would be something different, yes, but at the same time it is decided by the normal thing. One more thing, internal surface coated है या outer surface coated है, it will decide this fact. तो इंटरनल और आउटर से ही उसको याद रखना है. तो यहाँ तक का सबका क्लियर है. यहाँ पर इंटरनल सरफेस इज लाइक अ कर्व्ड सरफेस, रिफ्लेक्टिव है. तो यहाँ पर मैं जहां पर भी एंगल देके मिरर या लाइट अप्लाई करूंगा तो इट विल बिहेव एज अ मिरर. तो लाइट वैसे ही बाहर निकलेगा. तो यहाँ पर ऐसे रखा हुआ है, सामने कर्व्ड है तो ये हो गया कनकेव, और पीछे वाला डाल दिया बेंट पार्ट, और यहाँ पर लाइट दूंगा तो दिस इंटरनल साइड इज कोटेड. तो दिस सरफेस विल बिहेव एज अ मिरर. तो यहाँ पर लाइट अप्लाई करूंगा तो इट इज विल रिफ्लेक्ट इन डिफरेंट डायरेक्शन. So you can remember like that, internal and external. There are some of the terminologies which you have learnt already in the 10th as well. So I am also repeating those quantities. Very first thing is called as whenever you are drawing your curved mirror, it is having one part. It is called as a radius, or it is called as a radius of curvature of mirror. So let's say radius of curvature of mirror. So what I'm doing is that I'm putting a simple normal small figure, तो उसको आपको दिखा सकता हूँ. So I'm taking one protector and I'm just drawing very curved part. So with the help of a protector, after doing such thing, this is my curved part, let's say. And this is my point of a curved part, that is called as a C. And let's say there are the surface of a mirror. Let's say this is the mirror surface M1 and M2. From the entire circle, I have chosen this much part as a reflective part. M1 and M2 would be there. So one imaginary line is passing from our point C to P, that is called as a CP is equals to R. This is called as our curvature or radius of a curvature of mirror. It is called as R. One more thing is called as our normal part. तो अभी normal किसको बोले? तो नॉर्मल का मीनिंग हुआ परपेंडिकुलर. तो राइट नाउ हमारे पास M1 एंड M2 इज बिहेविंग एज अ सरफेस और नॉर्मल पार्ट. इट इज हैविंग वन पार्ट, इट इज कॉल्ड एज एपरेचर भी बोल सकते हैं, और उसको बोलते हैं लीनियर एपरेचर. So there are two things we have learned right now. Is that the very first thing is called as our radius of curvature of a mirror. Radius of curvature of mirror किसको बोलेंगे कि जब भी हमारा मिरर को हम लोगों ने ड्रॉ किया है on a plane of a paper, तो where our point, or you can say that a sharpened part of our protector we have placed, from that it's a curved part would be there. The distance between the C and P is called as a point, or you can say P is called as a pole. Whenever we will just follow that sign convention, pole will be considered as our origin. So pole is one axis part, it is called as a 0 point part. So the distance between the C and P is called as a CP, is called as a R, is called as the radius of a curvature of a mirror. M1 and M2 is behaving as a curved surface, it is called as a normal. consider कर लेते हैं हम उसको, या तो एपरेचर भी बोल सकते हैं. और हमको ऐसा दिख रहा है फिगर में कि M1 और M2 जो है वेरी कर्व्ड है, बट इन अ प्रैक्टिकल अप्रोच हम लोग जब भी मिरर्स को देखते हैं वो इतने कर्व नहीं होते हैं. इट इज हैविंग वेरी स्लाइट कर्व पार्ट, तो हम लोग उसको नॉमेनक्लेचर दे देते हैं लीनियर एपरेचर. तो एक हो गया हमारा रेडियस ऑफ कर्वेचर ऑफ अ मिरर, और एक हो गया हमारा लीनियर एपरेचर. एक छोटा वाला एक मोर यूनिट डाल देते हैं, देन वी विल डिस्कस अबाउट मोर रिलेशनशिप एज वेल. वन इज कॉल्ड एज अ एफ, इट इज कॉल्ड एज अ फोकल लेंथ. हम लोग उसको स्मॉल एफ में डिराइव करेंगे. तो दैट इज कॉल्ड एज हाफ ऑफ द रेडियस ऑफ द कर्वेचर ऑफ आवर मिरर. इट इज कॉल्ड एज अ फोकल, और यू कैन से फोकी पॉइंट्स. तो आप लोगों को पता ही होगा कि फोकल पॉइंट और उसका रिलेशनशिप कुछ ऐसा है, 10th में पढ़ा था आप लोगों ने. F इक्वल्स टू R/2, फोकल लेंथ इक्वल्स टू रेडियस बाई 2. तो ये तो आपका 10th का ही स्टडी है. तो इट वुड बी हाफ समवेयर ओवर हियर. तो लेट्स से मैं दे देता हूं यहाँ पर in front of your figure that C to P is called as R. So focal point is called as F somewhere over here. It is called as a half of the radius of the curvature of the mirror. तो तीन quantities हो गई initial mode में. तो that is very first part, second part and third part. R, F and you can say radius of curvature and normal as well. I am putting one more focus on the very small quantity over here is called as a principal axis. We will discuss about this over there in the next lecture. The principal axis is called as an imaginary line passing from the pole of the mirror is called as a principal axis. One imaginary line which is passing from the pole of the mirror is called as a principal axis. It is very much useful to put a sign convention. So in the next lecture, we will discuss about our sign conventions